Have you ever walked right up to a fence or a brick wall or the edge of a cliff and looked out? When we reach a boundary, our brains are hardwired to ask a very simple question. What is on the other side? We cannot help it. It is how we explore. It is how we understand our world. If there is a line drawn in the sand, we want to know what happens when we step over it. So, naturally, when we look up at the night sky, past the stars, past the glowing dust clouds and the spinning galaxies, we push our imagination as far as it can go. We imagine the entire universe stretching out in all directions, and then we imagine an edge, a great cosmic wall, a boundary line where everything stops. We ask that same irresistible question: what lies beyond the edge of the universe? Is it just endless, empty space? Is it a dark void? Or is it a sea of other universes, stacked up together like foam on the ocean? I have spent my whole life wrestling with the rules of nature. I can tell you this. The answer is not just strange. It requires you to completely throw away your everyday common sense, because the trick is not figuring out what is outside the box. The trick is realizing that the box itself is a profound illusion. There is a magnificent paradox hiding in the dark, and we are going to tear it apart together. If you want to pull back the curtain on reality with me, hit that subscribe button and let us take a walk to the very end of everything. What you find there is going to bother you in the best possible way. Let us start with something familiar. Imagine you are driving across the country. You are on a long, flat highway, the kind that stretches on for days. As you look out the window, you see fields, towns, maybe some mountains in the distance. And no matter how far you drive, you know that eventually, if you keep going in a straight line, you will hit an ocean, a literal edge to the continent. Our brains are built on this kind of geography. Everything we touch, everything we build, has a beginning, a middle, and an end. A table has an edge, a room has walls. Because we grew up in this world of neat little boxes and clear borders, we take that logic and we just paste it onto the cosmos. We imagine the universe as the biggest box of all, a giant room containing all the galaxies, all the stars, and all the empty space. And if it is a room, it must have walls, right? If you got into a rocket ship that could travel impossibly fast, you just flew in one direction for billions and billions of years, surely you would eventually hit the boundary of the universe. But nature does not care about what makes sense to us. Nature operates on a completely different set of rules when you zoom out to the scale of the cosmos. To understand this, we have to go back to the beginning, the very beginning. About 13.8 billion years ago, you have all heard of the Big Bang. But people have a terrible habit of picturing the Big Bang wrong. Even very smart people do this. They picture an empty, dark space, and suddenly a massive explosion happens in the middle of it, like a firecracker going off in an empty warehouse. They imagine all the matter, all the stars and gas, flying outward from that center point, expanding into the empty space around it. If that were true, then yes, the universe would have an edge. It would be the outermost layer of all that flying debris, and beyond it would be the pre-existing empty void. But that is completely, utterly wrong. The Big Bang was not an explosion in space. It was an explosion of space. Think about baking a loaf of raisin bread. Imagine the dough is space itself, and the raisins are galaxies. As the bread bakes and expands in the oven, every single raisin moves away from every other raisin. If you are sitting on one raisin, you look around and see all the other raisins moving away from you. You might think you are in the center of the loaf. But the person on the next raisin thinks they are in the center. The truth is, there is no center. The dough itself is swelling. Now, take that bread and imagine it does not have a crust. Imagine the dough just goes on forever. Endless dough, endless raisins. When that endless dough expands, it gets less dense. The raisins get farther apart. But there is no edge expanding into an empty oven. There is no outside. There is just more space being created everywhere, all at once. Space itself is stretching. When we say the universe is expanding, we do not mean galaxies are flying through an existing room like shrapnel. We mean the fabric of reality between the galaxies is literally stretching out. This stretching is happening everywhere. So if space itself is the thing that is expanding, there is no empty void outside of it waiting to be filled, then the whole idea of an edge starts to crumble. You cannot have an edge to reality if reality itself is all there is. But this brings up a terrifying problem. If there is no edge, does that mean the universe goes on forever? Or does it somehow wrap around itself? If you keep flying in a straight line, what exactly happens? The answer forces us to look at the very shape of reality. And I promise you, it is far weirder than a simple infinite void. Let us think about our own planet for a second. Hundreds of years ago, people were terrified of sailing too far out into the ocean. They looked at the horizon and they imagined an edge. They thought if you sail far enough, you reach the boundary of the world. You fall off into absolute nothingness. But then we realize the earth is a sphere. Imagine a tiny ant walking on a massive beach ball. The ant just keeps walking forward in what it believes is a perfectly straight line. It can walk for days, or weeks, or years. It will never, ever find an edge. There is no cliff. There is no boundary line. But, and this is the crucial part, the beach ball is not infinite. It has a very specific, limited size. The ant just eventually walks all the way around the curve and ends up exactly where it started. Could our universe be doing the exact same thing? Could three-dimensional space be curved, folded back on itself in some higher, mysterious dimension? If that is true, then if you get into a spaceship and fly in a perfectly straight line forever, you will never hit a cosmic wall. You will just eventually arrive back at Earth. you would literally be able to look through a powerful enough telescope, wait long enough, see the back of your own head from billions of years ago. This idea makes a certain kind of mathematical sense. It gives us a universe that is finite, but has no edge. It wraps up the boundary problem beautifully. It makes us feel safe. But we are physicists. We do not just sit in armchairs and imagine pretty shapes. We measure things. We test reality to see what it is actually doing. So, how do you test if the whole universe is entirely curved? You use basic geometry, the exact same geometry you learned when you were a kid in school. If you take a pencil and draw a triangle on a flat piece of paper, the three inside angles will always add up to exactly 180 degrees. It does not matter how you draw it, they always add up perfectly. But what if you draw a triangle on the surface of a basketball? If you start at the North Pole, draw a line straight down to the equator, go a quarter of the way around the equator, then draw a line straight back up to the North Pole, you have created a triangle with three 90-degree angles. Those angles add up to 270 degrees. The curve of the ball distorts the math. So we did this with the cosmos. We drew the biggest triangle we possibly could. We used the oldest light in the universe, the leftover thermal glow from the Big Bang itself, to measure the angles of massive cosmic triangles stretching across billions of light years of space. We sent satellites into the freezing dark to get the precise numbers. And what did we find? The angles add up to exactly 180 degrees. The universe is flat, dead flat. At least the portion of it that we can see is so incredibly flat that any curvature must be absurdly huge, way beyond our horizon. Now, pause and really think about what that actually means. It is completely flat. It is not curved like a balloon. It does not neatly wrap back around on itself. And as we established earlier, there is no outside void, which means there is no edge. Space is fundamentally flat, and it has no physical edge. Then our brains are forced into a very uncomfortable corner. The only logical option left on the table is infinity. A universe that simply never stops. Endless space. Imagine flying past our observable bubble, past the farthest, oldest galaxies our telescopes can capture, and finding just more galaxies, and more stars, and more black holes forever. Infinity is a fun word to throw around in casual conversation, but in physics, infinity is a nightmare. It is a monster that destroys our understanding of nature. When you introduce true infinity into the physical world, reality starts to break down in ways that will make your head spin. Because if the universe is truly infinite, the basic laws of physics are the same everywhere. It means that the math takes over. And the math demands something completely absurd. This is where the mystery stops being a simple map and starts becoming a deep existential paradox. Let us talk about infinity. People use that word all the time. A child will tell you they love you to infinity. A poet will write about the infinite depths of the human soul. It sounds beautiful, but to a physicist, true infinity is a monstrous concept. It breaks the very foundation of how we experience reality. To understand why an infinite universe is a paradox, we have to look at something very small and very finite. We have to look at how matter works. I want you to picture a standard deck of 52 playing cards. If you sit at a table and shuffle that deck, you create a specific order of cards. Now, the number of possible combinations you can create is staggeringly huge. It is an 8 with 67 zeros after it. It is a number so large that if you shuffled a deck every second since the universe began, you would not even come close to seeing a fraction of the possibilities. But here is the absolute, unavoidable truth. That number is huge, but it is not infinite. It has an end, which means if you had an infinite amount of time and you just kept shuffling and shuffling forever, what would happen? Eventually, you would run out of new combinations. You would have no choice but to shuffle a sequence you have already seen before. If you keep going forever, you will shuffle every single combination an infinite number of times. Cosmos. This is not a guess. It is a mathematical certainty. Now, let us take that logic and apply it to the universe. Everything around you, your chair, the floor beneath your feet, the blood pumping through your veins, it is all made of atoms. And those atoms are made of smaller particles. In quantum mechanics, we know that in any specific volume of space, there's a strict limit to how much energy and matter you can pack inside it. Because of this, there is also a strict limit to the number of ways you can arrange those particles. Think of our observable universe, sphere of light, spanning tens of billions of light years, that we can currently see as one giant deck of cards. The number of ways you can arrange every single atom, every single photon, every single speck of dust inside this bubble is practically beyond human comprehension. It is a number so large that it makes the deck of cards look like nothing. But just like the cards, the number of possible arrangements inside our cosmic bubble is finite. Are you starting to see the trap we have walked into? We measured the universe. We found out it is perfectly flat. Because it is flat, and because it has no outside edge, the only logical conclusion is that space goes on infinitely in all directions. So, we have an infinite amount of space, but we only have a finite number of ways to arrange the matter inside any given chunk of space. When you force a finite number of possibilities into an infinite amount of space, the laws of probability stop being a game of chance. They become a heavy, crushing inevitability. If you get into a ship and travel in a straight line out into the infinite expanse, past the edge of our observable bubble, you will see new things for a very, very long time. You will see bizarre galaxies, strange stars, planetary systems we cannot even begin to dream of. But eventually, if you keep going, you will run out of new ways for atoms to be arranged. And just like the deck of cards, reality will be forced to repeat itself. If you travel far enough, you will eventually find a bubble of space where the atoms are arranged exactly, particle for particle, like the bubble we live in. You will find another Milky Way galaxy. You will find another Earth. You will find another you sitting in the exact same spot, listening to these exact same words at this exact same moment. And because space is infinite, there is not just one copy of you. There is an infinite number of you, stretching out forever into the dark. This is the paradox. We started by looking for a simple physical boundary to the universe, and instead the math led us to an infinite house of mirrors. Disturbing as this is, it is only the first layer of the problem. Because the rules of physics have another trick up their sleeve, it is going to break your brain completely. So, nosotros have followed the logic to a deeply unsettling place. We measured the cosmos, found it to be flat, and realized it must be infinite. And because the arrangements of matter are strictly finite, that infinite space must be filled with endless copies of you, me, and our entire galaxy. You can say that this was the ultimate limit of how strange nature could be. Yo me di cuenta very quickly that I was wrong. Mira esto, kudin. We need to look closer at the engine of the universe itself to find the real break in our reality. We need to talk about the spark that lit the fire. We talked about the Big Bang not as an explosion in space, but an explosion of space. But what actually drove that explosion? Space does not just stretch itself for no reason. There had to be a mechanism, a kind of repulsive gravity that pushed everything apart at speeds far faster than light. Physicists call this rapid stretching process inflation. Think of inflation like a block of ice melting into water. It undergoes a change in state, releasing a massive amount of hidden energy. In the first fraction of a second of our universe, space itself underwent a phase change, expanded so violently and so rapidly that a region of space smaller than an atom was blown up to the size of a galaxy in an eye blink. Then, in our region of space, this inflation stopped. The energy driving it dumped into our cosmos, creating all the heat, light, and matter that we now see. Stretching slowed down, and our universe began to cool. But here is where the math refuses to cooperate with our comfort zone. When we calculate how this inflation works at a quantum level, nosotros find something horrifying. Inflation does not just stop everywhere all at once. Imagine a pot of water on a stove brought to a violent rolling boil. Bubbles of steam form, grow, and rise to the surface. The liquid water is still there, continuously boiling, but inside those little bubbles, the boiling has stopped. They are isolated pockets of steam. According to the laws of quantum mechanics, the rapid stretching of inflation is exactly like that boiling water. It is a continuous, never-ending process. It is happening right now, out there, beyond our physical reality. Space is constantly inflating at an unimaginable speed forever. We call this eternal inflation. And in that eternally inflating ocean, little regions suddenly stop inflating. They undergo a phase change, releasing energy and creating a universe. Our universe. Our Big Bang was not the beginning of everything. It was just the moment that the boiling stopped in our specific little bubble, but the ocean is still boiling, which means there are other bubbles forming, endless number of them, constantly, forever. Now try to hold this in your mind. Nosotros just established that our universe, our single bubble, completely flat and infinite in size. If you travel inside our bubble, it goes on forever and repeats itself. But our infinite universe is just one single bubble in an endlessly boiling ocean of other bubbles.